Do you know black holes do cast shadows? Yeah, and it is different than conventional shadows. When I say conventional shadow, I mean you have something between the source of light and you, that something would block the source of light, thereby casting a shadow on you. But black hole shadows work a little bit different. This with some other interesting stuff about black holes we are going to see in this video. For this video, we'll have to choose a character. Let's choose a character named Bob. Bob is very curious. Bob is so curious about knowing everything that he decides to jump into a black hole. There are three things that Bob needs to take into consideration. One, the event horizon, the spaghettification point, and the accretion disk. The gravitational force on your leg is a little bit higher than your head because legs are a bit closer to the center of Earth. Since the gravitational difference between head and leg is not that big, so you don't feel spaghettification. But that is not the case with black hole. With black hole, the gravity is so intense that it'll stretch you like a rubber band, and not only that, it'll break you into pieces. The spaghettification point depends on the size of the black hole, and counterintuitively, you may think that bigger the black hole, it will have its spaghettification point way beyond its event horizon, but that's not true. Actually, the inverse is true. Smaller the black hole, the spaghettification point is even bigger. So, for example, the smallest black hole that we have seen is just 20 kilometers across, and its spaghettification point would be somewhere around 60 kilometers. However, a black hole, let's say, which is 3 million kilometers across, it will have a spaghettification point somewhere around 24,000 kilometers. So Bob wants to choose a bigger black hole. But bigger black holes just don't hang around alone. They take a lot of stuff around with them. There's gas and dust that revolves around black hole at ultra high speed. This is what is called as a quasar. A quasar can be as bright as 1,000 times all the stars combined within a galaxy. In fact, when it was discovered, scientists mistook it as stars, and that is why it was called as quasi-stars or quasars. But if Bob goes to a black hole big enough to have quasars, he'll be instantly vaporized. So he must find a black hole that is big but that has relatively calm accretion disk. Much like Gargantua. What is the event horizon? Event horizon is a point where black hole starts, or the definition of black hole starts. So black hole is itself, it's a sphere in space where gravity is so intense that not even light can escape. Light has no mass, and it also gets affected by gravity. Not because of mass, because of distortion of space. Space within the range of black hole gets so distorted that even light has to revolve and then eventually go to the black hole and does not come out. Okay, now Bob took all these points into consideration and he chose a black hole. As he's approaching a black hole with his friends, at about 3 times the radius of the black hole, Bob will see that accretion disk has ended, but event horizon has not started. That space would be empty, would be very quiet. So this is the point where the accretion disk ends. However, the event horizon is not yet started. And this is the point where he'll see even light revolving or taking a circular path. In fact, light will be a perfect circle. Why? Again, the same reason, because the space is so distorted, it becomes, light has no way but to follow a circle. In fact, if Bob were to look sideways in perpendicular direction, he'll be looking right back his head. At 2.5 times the radius of the black hole, Bob will enter in what is called as shadow of black hole. Black hole of radius r will cast a shadow of 2.5 times r. Why? You see, black hole not only it blocks the light that is coming from behind, but also attracts all the photons that is going up and below towards it that would otherwise hit the eyeballs of Bob. So Bob will not be able to see it. He'll see a big black circle thinking that it is the black hole. Now remember that Bob is accompanied by his friends. And if they wanted to take that perfect photograph of Bob, this would be the time. Bob, even though 2.5 times away from the black hole, he'll be engulfed in complete blackness and would be a perfect position to smile back and then get that photograph. Now, as Bob continues his journey, at about 1.5 times the radius of the black hole, this is the point not even light can escape. In fact, light will start to spiral down into the center of black hole. This is the point at which if Bob wanted to see the entire universe, he could look back and he'll see the entire universe. In fact, at the edges, he would see the same pattern repeating again and again and again. So what happens when Bob crosses the event horizon? Well, nothing much. In fact, if you would think that Bob will basically get sucked right into the black hole, or he would find some galactic guards standing there. No, nothing like that. Event horizon is just a place, in space where it's just point of no return for light even. And just before event horizon is the place where Bob's friend will be able to see Bob frozen in time. In fact, they'll see him turning red, not because Bob is turning red, but just because photons are getting redshifted, and they'll see him frozen in time. In fact, if they would have waited for trillion years, Bob will not move an inch. So now, as Bob crosses the event horizon, what does really happen? If you take general relativity to be true, which is true 99% times, it's not true always. Take for example, general relativity fails at quantum level. If general relativity is really true, what happens inside the event horizon, then, well, there's nothing dramatic happening. Bob will get sucked right into the center of black hole and he'll hit the spaghettification point. Yep, that point. And then he'll be pulled as a rubber band and then, shredded into bits, and that'll be the last of him. That general relativity isn't true just after the event horizon, then interesting things can happen. So here are a few things that physicists have proposed what really happens inside the event horizon. First is entire another universe. Bob may be popped into another universe, or he may be part of new universe altogether that has just taken birth, or it could be another wormhole. So now that black hole is black, there is something called as white hole, which is white. Black hole is a place where all the dimensions point inward. White hole would be a place where all the directions point outward. Means once you're popped out of the white hole, there is no way that you can come in. Yeah, but sadly, in either case, this will be the end of Bob for this universe. Once inside the black hole, it is very unlikely that Bob will ever be able to come out. He may be, hale and hearty in some other universe, or within the black hole, or he may spot a monkey eating banana at the center of black hole. Who knows? One thing is for sure, only Bob would know what happens inside the event horizon. Either he would have a horrific death, or he would be thrown out in another universe, and he would have no way to tell this to any one of his friends or anything in this universe. Alright guys, hope you liked this video. Please hit that like button, share it with your friends, subscribe to the channel, and put your valuable comments in comment section. I'll see you next time around. Bye bye.